Something looks red right now. Why do I seem like I'm squashed? If I do this. No, it looks like you're looking at my nostrils. Go back here. I feel like you're looking at my nostrils. And that's squished in a funny way. Hello. Sorry, I'm trying to figure out this camera here. Because I either get the look up my nostrils, if I do that, or if I go back to the other one, that one, then for some reason I look lopsided. So, anyway, welcome everyone. I hope you guys, hope studying's going well for everyone. I'm also busy with my studies at the moment, so yeah, it's been a bit crazy. There we go. So welcome everyone. I'm gonna wait a little bit so we have a few more people to join, and then I think we'll jump into sequences and series. I've got a few, so for those who want to get papers already, I've got the Limpopo 2020 September paper. I've got the Eastern Cape September 2022 mock paper that went out. And then the other one that I have here is the September 2020. Where's this one from? This one just says, okay, well, let me find where I got it from, and then I can tell you. No, not that one. I think it's the Eastern Cape one, to be dead honest. Yeah, it's the Eastern Cape September 2022 prep paper. Sorry, not Eastern Cape, KZN. Can you guys hear me? Just let me know in the chat if you can hear me properly, please. Okay, so you guys can hear me. Okay, so for tonight, we're going to be doing sequences and series and probability and then calculus. Okay, so if you guys have any, okay, cool, you guys can hear me, perfect. If you guys have any questions, then please just pop them in the chat below. If you have a specific past paper question that you want me to look at, let me know and I'll see if I can find it quickly and then go through it. So yeah, I think let's jump into it. I think I'm going to start with the, let's have a look here. Let's do the Limpopo one. Okay, so let me just swap cameras quickly. Let me just get this set up here, started. That needs a thumbprint. Aha, there we go. All right. Let me swap around to this camera. And we can get started. Just let me know if the stream becomes laggy or anything like that. Okay, there we go. Okay, can you guys hear me now? I don't know why I spoke louder. Yes, okay, so you can hear me through this camera, but not through the other one. Okay, let me just restart it on the other one up here. So I'll just sort this out. Just restart the program, and then we can try again. Okay. Okay, I'm gonna swap cameras and then we can see if you're picking up sound. One. Okay. Oh, let's just zoom in there. Can you guys hear me now? Okay, so you can hear me. Okay, cool. Can you see the screen clearly now as well? Or is it a bit fuzzy? Okay, perfect. Okay, so one person says no, the other one says yes, perfect. So can just let me know if you can see the screen. Sorry, I haven't done this in a while. Okay, if I write, let me know if you can read what I'm writing. Okay, yes, no. Okay, so we've got some people saying yes, we've got some people saying no. Okay, let me know if you can read. Okay, and let's zoom out a little bit. There we go. Okay, can you read that? Otherwise, I must just adjust the other way around. No. Okay, so I need to swap it around. So if I do that, now can you read it? I'm writing backwards. Okay, is it the right way around now? Yes. Okay, all right. Okay, so you can hear me, but you can't see. Perfect. Yes, that's better. Yes. Okay, yes, but the other way. Okay, there we go. Okay, so let's have a look here with the first question that I want to look at. It's from the Limpopo September 2020 paper. Okay, it's question 2. Let me fold this in half so we're dealing here. So it says the following sequence is given. Okay, so let me just write out what the sequence is given over here. So they give us the following over here. We have so question 2 from Limpopo. Okay, and that's the 2020 mock paper. Okay, so they give us the following. They say we have -6, then we have 2 minus x, and then 4, and we have 2x plus 5. Okay, and then they're literally asking us to solve for x. Okay, so question 2.1 says find x. Oh, they also tell us that it's quadratic. Okay, so we need to now solve the following quadratic over here. Okay, so if you want to have a crack at that, then I'll give you guys a few minutes to attempt that, and then I shall go over it. Okay, sequence given -6 minus x, then 2x plus 5, and then they've asked you to solve for x, and then question 2.2 we'll be looking at so 2.2 find general solution. Okay, and we'll look at the form of Tn equals to an squared plus bn plus c. Okay. Pattern. So it's -6. Okay, then it's 2 minus x as your next term. then your third term is 4, and then your fourth term is 2x plus 5. Okay, so just a key note you have to take into account. Remember, quadratic has two differences, so there's a second difference that you have to take into account there. Okay, so if you're struggling to figure out how you're supposed to solve for x, could you write a bit bigger? Okay, I'll write a bit bigger. Yes. Okay, so quadratic's got two differences. Okay, so this is 6, that's 2 minus x, 4, 2x plus 5. Okay. All right, and that's for, let's have a look at this, for 3 marks. Okay, so if you look at the total for your paper, just the key thing, your paper's out of 150. Okay, so if you take 3 hours, which is 180 minutes, you divide it by 150 marks, you should be spending 1.2 minutes per mark. Okay, so times that by 3, it's 3.6 minutes for this question. Okay. All right, let's jump into it. So in order to solve this, what we need to do is we know that there's a second common difference. Okay, so let me write it out here again. So we have minus 6, then we have 2 minus x, and then we have 4, and then we have 2x plus 5. Okay, so in order to solve this, we know that this has to be a difference over here. Okay, so therefore it's this one to that one. So you can have 2 minus x, okay, minus 6. If you take the difference between those two, the difference between here is then 4 minus 2 minus x. Okay, just be careful with your negatives. And then the difference from here to here would be 2x plus 5 minus 4. Okay, so if we sort that out over there, 6, okay, 2 minus 6, x equals to 5. Well done. Okay, well done on solving that. Okay, so the main thing is you've got to find your second difference over here. Okay, and then you'll have a difference between those two, and you'll have a difference between those two. Let's just check over here. I've written them the wrong way around. This should be, have I? No. Okay, so it's negative 6 minus, it's minus minus, so that becomes a plus. See, even I forgot it there, the negative over there. Okay, so then for this one over here, okay, it simplifies down to 8 minus x. Okay, then this one over here is 4 minus 2, which then gives you 2 plus x. And then over here, you're going to end up with 2x plus 1. Okay, and then you take the difference between those two over there. So it's, I need to write bigger, sorry. 8 minus x. Okay, and then you're minusing off that term over there. So it should be the other way around. 2 plus x minus that. And then for these two terms over here, it's 2x plus 1 minus 2 plus x. Okay, and therefore you're going to get, remember, these two differences need to be equal to each other. So I'm going to just do adjust. So you're going to end up with 2x minus 6 if you sort this out over here. Okay, and then that's going to be equal to, let's see, if we solve this one over here, we're then going to get to 2x minus 1. There we go. Okay, and then if you just solve your algebra here, you then should get that x equals to 5, correct? Okay, so that one's not too difficult. The only thing is you need to know that quadratic has second difference over there. Okay, and now if we look at 2.2, it says solve the general solution for Tn equals to an squared plus bn plus c. Okay, so now that you have x over here, we can solve the rest of the sequence. So the sequence is, let's see, the first term is minus 6, then 2 minus 5 gives you minus 3, then we have 4, and then 2 times 5 is 10 plus 5 is then 15. Okay, and then you can just solve down your second differences over here. So from there to there, we add 3. From there to there, we then end up 3, 4, so that's plus 7. And then from there to there, we're going plus 11. So the common difference there is 5, as we found. Okay, so therefore we know that 2a equals to 5. So therefore you got to get that. Sorry, what am I saying? X equals to 5, but that doesn't mean our common difference is 5. That's 4. Sorry, I'm smoking my socks tonight. Okay, so that's 4. There's 4. So therefore a equals to 2. Okay, then we know that a plus b plus c equals to our first term, which is minus 6. Okay, but we need to find b first. So b is given as 3a plus b equals to your second difference, which is 3. So we're going to have 3 times 2 plus b equals 3. So b equals negative 3. Okay, 2n squared minus 3n. Perfect. I'm liking that. Well done. Okay, and then we're going to end up with 2 minus 3 plus c equals to negative 6. Okay, so therefore you're going to solve c to be negative 5. Once you sort all this out over here. Okay. And then if we just write that out, that's tn equals to 2n squared minus 3n and then minus 5. Okay, that's how we do that one. So 7 marks, quick, easy, simple, in the bag. Okay. So the next one that they give us here is a little bit of a longer question, and it's a little bit of a more complicated one, if you could put it that way. So I'm going to go through question 3, and then I'll do question 4, which has got to do with summation. Okay, this one always seems to catch you guys out. So let's have a look at question 3. So it says the first 2 terms of an arithmetic sequence, series A, and the infinite geometric series B are the same. Okay. So let me flip this over. Okay. So we've got A over here, which is 2 minus 2 plus A plus dot dot dot. Okay, going down. Okay, so A is arithmetic. Okay, and then B, which is given over here, let me write it over here. B is minus 2 plus A as well, but they say that B is geometric. Okay. Write down in terms of A. Okay, so the first one, yeah, so 3.1.1. Okay, so this is what they've given you, that A is arithmetic, okay, it's a series, and B is geometric. It's minus 2 plus A, minus 2 plus A. So they both have the same, okay? So 3.1.1 says the third term in the geometric series B. So we want the third term in the geometric series B, and we want it in terms of A. Okay. So do that one, and then 3.1.2, they say the third term of A, so the third term in the arithmetic series in terms of A. Okay. So try that one. Okay, it's for 2 marks. Both of them are for 2 marks. So it shouldn't be too difficult to figure out. Okay. The key thing is knowing that what does arithmetic mean and what does geometric mean. Okay, so give a few more minutes on that, and then we can have a look at that. Okay, so let's jump into this here. Okay, so the first one's asking for the geometric series, so B. Okay, so let's have a look at geometric means what? Geometric means that there's a common ratio. Okay, so now we just want T3 in terms, we want T3 in terms of A. Okay, so we need a common ratio. So let's just do 3.1.1 for geometric. So we need a common ratio. So therefore, if we want to find a ratio, it's then going to be T2 over T1. Okay, nice, I'm liking it. Okay, so negative A squared over 2, well done. Okay, so how do we get there? We have A over negative 2. Okay, so that gives me my ratio. Okay, and now all we need to do is find T3. Okay, so T3 means we then take T2 and we multiply it by our ratio. Okay, so T3 is going to equal to T2 multiplied by A over negative 2, which then going to give you A multiplied by A over negative 2, which equals squared over negative 2. Perfect. Okay, or you can put the negative at the top, doesn't make a difference. Okay, now if we look at 3.1.2, it says the third term of the arithmetic sequence. So what's the difference? Or an arithmetic sequence has a common difference. Okay, so the common difference is then just going to be difference between these. So it's A minus 2. So that becomes, and then we want 3, which then equals to A plus 2A plus 2. Okay. Now 3.2, okay, system so well, it says the sum of the first 3 terms in the arithmetic sequence A is equal to the third term of the geometric sequence B. Okay, so it's saying that this is 3.2. It's saying that minus 2 plus A plus 2A plus 2 equals T3 of B. Okay, so then it says, okay, so that's what they've told us here. Okay, then it says write down the equation to determine the value of A. Okay, let's read it. It says the sum of the first 3 terms in the arithmetic series A is equal to the third term of the geometric series B. Write down the equation and determine the value of A. Okay, find the value of A. Okay. Now remember that. Hold on. Do I have the wrong thing? Yeah, I do. This is the wrong thing. Okay, so we need negative 2 plus A plus. Let's see. We want this one over here. Okay, so that's A squared over minus 2. Okay. So using this, we got to solve for A. Wait, hold on. I'm confusing myself here. So the sum of the first 3 terms in the arithmetic sequence. Yes, I was on the right track. Okay, so let me rewrite this out here. Okay, so we have minus 2 plus A. This is the arithmetic one, plus 2A plus 2. Okay, so the sum of all of this needs to equal to the third term in the geometric sequence. That's got to equal to, what's that, A squared over minus 2. And then you need to solve for. Okay, so let's have a look. How do we go about doing this one? So we know, let's have a look at the formula for the sum of an arithmetic sequence. Okay, so that is given as n over 2. Then it's 2 times your first term. Okay, so let me call that capital A. Plus, what's that, n minus 1 times your common difference. Okay, and then we're looking for the third one. Okay, so therefore we're going to have 3 over 2 what's our first term? Our first term is -2, okay, and then plus, we're dealing with 3 minus 1 times our common difference. What was our common difference? It was a plus 2. Okay, and that's all got to equal to a squared over -2. Okay, quite a question, this one. So let's sort this out quickly. Let's go down here. So that's going to be 3 over 2. That's -4. That becomes 2. So that is plus 2a plus 4 equals to a squared over -2. Okay, and if I have my maths right here, that one and that one cancels out. This 2 and that 2 cancels out. So therefore, we're left with 3. Wait, let's see. That's -4. 3 minus 2. I mean, minus 1 gives you 2. Times 2 is 4. Okay, but that's plus over there. Let's see. There's a 2a over there. Sorry. Okay, so therefore that's times 2a over there. And then that is all equal to -a squared. Okay, there we go. So this 2 and that 2 will cancel out, but then this 2 is going to come across. I'm going to leave the negative there. Okay, so technically we have 6a equal to -a squared. Okay, and therefore we can just take out a as a common factor. If I take that this side, so we have 6a plus a squared equals 0. So we have a 6 plus a equals 0. So a. Now we've got that. So they want us to determine the value of a. Okay. So a is either going to be 0 or a is going to be -6. Okay, and now the last question for question 3 says, if a equals -6, does the geometric series B converge? Show your calculations to support your answer. Okay, so we're dealing with convergence. What does convergence mean? Convergence means that if I had to continue adding all of these points up, we're going to end up at a fixed point. Okay, so it's going to get closer and closer to a single. Okay, so let's just see. Maybe I can squeeze this in here. Okay. So if a equals -6, so a equals -6, will the geometric series converge? That's what they're asking. Does B converge? Okay, so we now know that B is given as the following. B was -2, then it's -6, and then the third term for B was, let's see, -6 squared over -2. Okay, so if we plug that into our calculator, what are we going to get? That's 36 divided by 2. It's 18. Okay, so we end up with this here being equal to -18. So now asking, will this converge? Okay, so now the key thing is, when does convergence happen? Convergence only happens when our ratio R is between 1 and -1. Okay, so let's see how we're going to do this. You can do the sum to infinity if you want. That could also show convergence. Okay, but the main thing for convergence is R, your common ratio, needs to be less than 1. So if you look here, R equals to a over -2, which equals to -6 over -2, which equals to 3. Okay, so therefore, because this is greater than 1, no, we're not going to have any convergence. Okay, that's the quickest way to show. The other way that you can do it is sum to infinity, but that's just going to take more time. Okay, this is just easier. Okay, any questions regarding this question, how I did something or anything like that? Okay, so I'm going to open the chat to questions if anyone has any questions. Okay, at any point in time, please just let me know if the stream goes funny or anything like that. Okay, so I'm going to give you guys, let me just copy the link here quickly. And then I'll paste it in chat where you guys can also get the papers It's a whole lot of past papers and things like that. Okay. So there's some practice questions if you want to practice any. Okay. All right. So I think I'm going to move on then to question 4, which is summation. Okay. For some reason summation seemed to freak everyone out. Okay. So you give us the following over here. 4.1 says determine the sum of p equals to 1 of x plus 2 to the power of p if x equals -5. Okay, so have a crack at that one. And then we can figure it out together. Okay, so the main thing is we're to the power of p. Okay, so you should think of what kind of series we're dealing with over there. If we're to the power, okay, this just goes to infinity. Okay, so try this one quickly. I'll give you guys about 2 minutes and then I'll give the answer to it. Well, let's say a minute. Sorry, camera's a bit shaky. Does anyone know which province set the final paper this year? Because I think it was last year, the year before it was Eastern Cape, so the screen is blurry. Okay, so I need to fix the screen. Let's see, maybe if I change the resolution. Tell me if by changing the resolution if that helps. There we go. Is that better? Yes. Because Okay, I'm just trying to get it to connect again. Okay, I'm back. Can you guys hear me? And I take it that everything is backwards. Just let me know if the whole setup's fine now. If everything's the right way around or if it's back to front, if you can hear me, if you can't hear me. Sound is better. Okay, cool. And the picture? Is the picture better? Okay, that's good. All right. Okay, so just to go back to the convergence, okay? So the question asked, if A is equal to 6, does the geometric series converge? Show calculations to support your question or to support your answer. Okay, so if we're dealing with convergence, okay, our common ratio needs to be a fraction. Okay, the reason why it needs to be a fraction, okay, something over, let's call it y, okay, where y can be any number, okay. So the reason why it needs to be that, because as we start summing up our points, so when it's a fraction, let's say that's the point that we what you call it, converge to. Okay, as we start adding it up, in the beginning we're going to add up quite large numbers, okay, because this fraction is still quite big. But as it gets smaller and smaller, we're going to start adding up smaller and smaller and smaller amounts here, okay, and it's going to get closer and closer and closer. Why? Because this fraction is going to get smaller and smaller up until I get to that point. Whereas if it's a whole number, let's say it's 5, okay, what's going to happen every time I keep adding everything up, it's just going to get bigger and bigger and bigger. Why? Because it's AR to the n minus 1, okay, so therefore this here is going to be 5 to the power of 2, then 5 to the power of 3 to the 4 to the 5, okay, and it's just going to grow exponentially. So this is going to take off like that. Whereas if it's a fraction, what's going to happen? It's going to come down and it's going to level off to a point of convergence. Okay, so that's why it is better, or that's why, not better, but that's why we always want R for convergence to be between 1 and -1. That means it's a fraction of some sort. Okay, but let's go back to question 4. I hope that's answered your question regarding convergence. Okay, but looking at question 4, it says determine the following over here. Okay, and then it says, yeah, determine the sum here if it exists. So if it exists. Okay, so how do we go about solving this? It's for 2 marks. Okay, so it's not too difficult. Okay, so x equals to -5, so I'm just going to rewrite this. It's the sum as p equals 1 to infinity. Okay, and then that's -5 plus 2 to the power of p, okay, which is then equivalent to the sum as p equals 1 to infinity of -3 to the power of p. So what's happening? We're going to say -3 to the 1 plus 3 to the 2 plus 3 minus 3, sorry, -3 to the 3 plus -3 to the 4, and so on and so on and so on. Okay, which means we're dealing with geometric. Okay, so therefore we can see that our common ratio over here is r equals to -3, and -3 is greater than 1. Therefore, this does not exist, and therefore we are not going to have convergence, or we're not going to have the sum. This is just going to tend to infinity. Okay, it's just going to grow forever and ever and ever. Okay. So to end off this kind of question, you can just say does not exist. Okay. All right. Let's have a look at the last one. So it says the powers of 2 are removed from the set of positive integers. Find the sum of the remaining integers. The powers of 2. Okay, so what are the powers of 2? Okay, so the powers of 2 are removed from the set of positive integers. Find the sum of the remaining integers. Okay, so they've given us over there 4.2, and it's 1, 2, 3, 4, 5, and then it goes all the way up to 998, 1999, and then 2000. Okay, so all the multiples of 2 are removed. Sum to infinity is equals negative 7 over 6. Okay, no, how did you get 7 over 6? Or negative 7 over 6 for question 4. Okay, so just be careful, because with question 4.1, they're saying determine if it exists when x equals negative 5. Okay, so you shouldn't be getting a value. Why? Because this here is going to end up being 3, so you have 3 to the power of p, okay, which is in geometric, which means that r is greater than 1, so therefore this whole thing diverges, which means it doesn't exist. Okay, now if we look at the bottom one there, okay, we're taking out all the multiples of, or the powers of 2. Okay, so we're taking out 2, we're taking out 4, then we're taking out 8, and then we're taking out, let's see, 2 to the 4 is 16, so we're left with 1, 3, 5, then the powers of 2, then 6, 7, then 8 is out, then we have 9, we have 10, we have 11, then we have 12, 13, 14, okay, so on and so on. And what they are asking us to do is they're asking us to find the sum of the remaining integers. Okay, so we need to sum up everything now. Okay, so how are we going to go about doing this? So we're just going to use our formula. So we know that the first term is going to be 1. So a equals to 1. Okay, what else do we know? We know that the length of the sequence is 1 to 2000. So if we look over here, starting at 1, we're going all the way to 2000. So including 1, we then just have L equals to 2000. Okay, and then what other piece of information do we need? We need N equals to 2000 as well. Okay, so why are we using this? Well, we want to find the sum of the first few terms, or the terms of the remaining part. Okay, so we can use the following formula where we have Sn equals to n over 2 a plus L. We have L, we have A, we have N. Okay, so therefore, pardon me, if we find the sum of everything, yeah, okay, think about it. The sum is going to be the sum of everything as it is. Okay, so the common difference is just 1 minus the sum of everything that's left. Okay, so we can take the total here, then we can take the power series and just minus the 2 from each other, and we're then going to get our answer. Okay, so if we calculate that over there, we've got 2000 over 2. A is 1 plus 2000. Okay, so if we solve for that, we are just going to get a big number of 2001,000. Okay, so that's the sum of everything. Okay. How is n still 2000? Okay, well, there's n equal to 1, n equal to 2, n equal to 3, n equal to 4, and we've got 2000 numbers. So therefore, n equals 2000 over here. 2000, not 200. Okay. L is the length of the series. So L, the best way to calculate L equals your final one, 2000, minus the beginning, which is 1, plus 1. That's how we count. Okay. Oh, you thought x is 5. Okay. Even if x was 5, you still wouldn't get a sum. Okay. So tabang, you still wouldn't get a sum there because then it's 5 plus 2, which then gives you 7. Okay, so you're still above 1. Okay. But going back here, L is 2000 minus 1 plus 1. Okay, which then just gives you 2000. Okay, so that's the total. If we sum everything up, we get 2,000,001,000. Okay. Now what we've got to do is we've got to take out all the numbers to the power of, or 2 to the power of something. So we've got to take out 2 to the 0. So we're taking out 1. We take 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, so on and so on. Okay, all the way up to, what's the largest number we can go? Okay, well, let's see. I think it's 2 to the power of 10. Let's see what happens if we go 2 to the power of 11. 2048. Okay, so the largest number we can go up to is 2 to the 10. Okay, so with this, it's sometimes just trial and error. Otherwise, you can break this number up. Okay. So now we've got to deal with this sequence over here. So if we sum all of that up, what are we dealing with? We're dealing with geometric. Okay, so geometric has a common difference. So therefore, we know that if we want to find the sum, okay, so this is equal to 1. So A here equals 1. Your common ratio over here equals 2. How many terms are we dealing with? It's 1 or 10 minus this one plus 1. So hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be 11. So n will equal to 11. Okay. So therefore, we're just using Sn equals to the first term, r to the n minus 1 all over r minus 1. So if we substitute in everything there, really need this help, or tomorrow going to be the death of me. I'm sure you guys are going to be fine. Just need to take a breath in your exam, and you guys will be fine. Okay. All right. So let's just get back to solving this one. So finding S of 11 equals your first term, which is 1. Your common ratio is 2 to the power of 11 minus 1 all over common ratio of 2 minus 1. And if we plug that into our calculator, we should get a value of, let's have a look there. So 1, 2 to the 11 minus 1 goes all over 2 minus 1. Okay, 2047. Okay, so now in order to find the sum, all we have to do is we have to take the sum of everything minus the sum of the powers. So it's just going to be 2, 0, 2, 0, 0, 1, 0, 0 minus 2047, and that's going to give you a value. Plug that into our calculator. 200, 1. I'm missing a 0. I am. There's a 0. Minus 2047. That's going to give you that large number of 1,998,953. Okay. So that's the sum of your integers up to 2000 if you take out all the powers of 2. Okay, any questions regarding this question? Or do you have any other questions on sequences and series from another paper that you want me to go through? Okay. Where's all those other papers? Here's my other questions. Let me have a look here. I want to look at this one next. Okay, so if there aren't any other questions from anyone else, then I think I'm going to move on to, there's number 2 from the September 2020 preliminary paper. This was the KZN one, as far as I know. So I'd like to look at these two here. Okay, and then we can move on to either probability or to calculus, whichever one you guys want to do next. Okay, so maybe I think I can run a poll in here if I can remember. Sorry for the shakiness. Engage with your audience. Start a poll. Okay, so we're going to do calculus. Or we're going to do probability. Or something else. Okay, so I'm sure you guys are going to do well tomorrow. I don't think the paper should. I don't think it's going to be too difficult. They're going to try and trick you out here and there, but I think you guys will be fine. Calculus. Okay, all right. I love calculus. So hold on. Wait. Might have a change. Yeah, probability. Okay, so probability is now winning. Something else. Okay, if you want to do something else, just let me know what is the something else you want to do. Okay. Let me have a look here. What's this resolution sitting at? That there. Okay. This resolution. Oh no, it comes very laggy. Okay. Will you go through both throughout the video? Yes, I will cover calculus and I will cover probability. Okay. Oh, now we're sitting at an even split. Calculus is a big section. Yes, it is. Okay, so calculus comes in 3 or 4 questions. You've got cubic functions. You've got finding the derivative, which is easy marks, and then it's your optimization question. Okay, so I did release a video on optimization. Last year's November paper, I released that yesterday. That was quite a nice question. Can you please send me the question paper, sir? Okay, so the link, I have sent the link. Let me find this one that I'm dealing with again. So I'm going to do question 3 over here, and this is, I think it's the KZN paper. Okay, so it's always good to practice other provinces' past papers as well. Okay, just to get a feel for, so let me just double check here. Yes, it's the KZN one. Okay, so I've put the link in the chat already. I'll post it again. Okay, can I reference this link? Pin message. Okay, so I've pinned the message. Okay, so if you click on that link and you go through, I'm doing the 2020 KZN paper. I think it's a September mock paper that they have on the website there. Okay, so I'll give you a few minutes or a few seconds to get the paper if you want, and then I'm going to jump into it. Okay. Oh, I'm going to have to get more paper. Okay. So I actually quite like this question because there was a very similar one. I think it was in the May-June paper, one of those. Okay. So what they've done is, they said the first 3 terms of the first difference of a quadratic sequence is 102, 108, and 114. Okay. So we've got some quadratic sequence that we're dealing with. Quadratic means we have second difference. Okay, so this is question 2, and it's the September 2020 KZN mock exam. Okay, so they've given us 102, 108, 114, Okay, and that's the second difference. Okay, the second difference. So, sorry, the first difference within the quadratic sequence. Okay, which means this comes down and we'll have a common difference between those two. So now it says 2.1 says determine between which two consecutive terms in the first difference will equal 2022. Okay, so now what you need to notice is the the first difference, not the second, the first difference. Okay, so here would be this would be the difference between T1 and T2. That would be the difference between T2 and T3. And then that would be the difference between T3 and T4. Okay, so what you need to notice is this first difference here forms what kind of sequence? Sequence. Okay, if you notice over there, we've got a first common difference here, and that is of 6 and 6. So we're dealing with a arithmetic sequence. So this is just arithmetic, which means we're dealing with Tn equals to a plus n minus 1 times your common difference. Okay, so a is then 102. Okay, then the common difference is 6. So that's n minus 1 times 6. Okay, so they're trying to ask between which two terms will you have a difference of 2022. Okay, so if we go and we look at that one over there, okay, all we need to do is we need to solve for Tn equal, we need to find when Tn equals to 2022. Okay, so we're going to have 2022 equals to 102 plus n minus 1 times 6. Okay. So, sorry. Just getting my ducks in a row. Okay, so now if we have to solve this out, we're going to have 2022 minus 102 equals to 6n minus 6. Okay, and then if we take that over, it becomes plus. So you're going to have 2022 minus 102 plus 6, okay, equals 1926, and then divide that by 6, gives you 321. Okay, so when n equals to 321, okay, and then between which two consecutive terms? So now we need the consecutive terms, so therefore between 321 and 322. Okay, so it's quite a nice question, that one over there, because you have to realize that your first common difference for a quadratic is just arithmetic. Okay, now it says determine the nth term of the sequence if it is further given that the third term of the quadratic sequence is equal to 310. Okay, so that makes things a little bit interesting. So this is 2.2. So they tell us the third term of the quadratic sequence is 310. So we've got a1, a2, and then we have 310. Okay. We know that the difference between here is 102, the difference between here is 108, and the difference between the next two terms, a4 is 108, is 114. Okay. And then this here is just 6 and 6. So now we need to find the general term of the following sequence. Okay. So what are we going to go about doing this? Okay. So we can find a, that's not a problem. So over here we're going to have that 2a equals my second difference, so a equals 3. Okay, not too difficult there. Can we find b? Yes, we can find b. So 3a plus b equals to 102. So 3 times 3 plus b equals 102. Okay, and if we solve that, we're going to have 102 minus 9, b equals 93, pardon me. Okay, now the next thing that we have to solve for is c. Okay, but what don't we have? We're sitting with a problem here that we don't have a1, which means we can't solve for c. So we're going to have that a plus b plus c equals a1. Okay, let me make this a capital A so we don't get confused. So that's capital A1. Okay, so therefore we're going to have 3 plus 93 plus c equals a1. Okay, but what else do we know? We know that the third term equals 310. Okay, so therefore we're going to solve this simultaneously. So I'm just going to go back up here. Okay, so we know that the general term Tn equals to an squared plus Bn c. Okay, so now we have at 310 equals to, okay, we've already solved a, which is 3 times the third term squared plus b is 93 times the third term plus c, which is what we want. Okay, so actually from here we can just find c. Okay, we don't even have to go here. That's if they wanted us to find the first term. Okay, so just solving this out. Okay, so it's going to be 310 minus 3 times 3 squared. And then let's see, that's minus 93 times 3 equals 4. So c is then going to equal to 4. So therefore the general term is going to be Tn equals to 3n squared plus 93n plus 4. Okay, so not too difficult of a question, that one. That's actually quite a nice question. Okay, any questions regarding this one? Anyone have anything that they want to add or ask, anything like that? Okay, all right. So looking at the poll over here, okay, we still tie on calculus and probability. So I think I might do, let me do calculus. Okay, because as you said, it's a big section. So let's maybe focus on some calculus. Can have a look at that, and then we can go into probability. Okay, so let me see if I can find some questions for calculus. Okay, let's just go through the papers that I've already had open and see what their calculus questions look like. How does everyone feel about first principle? Just let me know what you guys, yeah. How's first principle? Sorry, let me just adjust this here. There we go. Before it falls over. Which paper is this again? Apologies, I know you've read. No worries. Okay, so this question here that I did was from the KZN September 2020 preparation exam. So it's just the mock exam. Skip first principle. Okay, so you guys are okay with first principle. Okay, so let's have a look at first principles are okay. All right. Well, if you're happy with first principle, then I'm happy with first principle, then we can move on. Okay. Let's see. Let's find derivatives. Okay. Because they love asking this, and some of them that they give you look very daunting, and it's actually not too difficult. Okay, so there's 3 ways they can ask for derivatives. Okay. So they can ask you to find y prime or f prime. Okay, so that means derivative. They can ask you to find d dx or dy dx. Okay, so it asks to find the rate of change. Or they can ask it in another way where they say the derivative with respect to x of a function on the inside f of x. Okay, so three main ways they can ask you to do that. So the first one, I'm looking at the Limpopo paper again. So Limpopo, September 2020. Okay, I'm just going to write them out. I haven't printed them. I'll go and print some of the papers now, and then we can go through them. So let's see. We have find the derivative of the following. So that's x plus 1 over x, and that whole bracket is squared. Okay, so what are they asking? They're pretty much asking find the derivative of the function squared. Okay, so what they're asking is find dx of x plus 1 over x squared. Okay, so it looks a bit challenging, but my advice, if you want to try this quickly, factorize it out and then do your derivative. Because to try and do the derivative here, you guys haven't learned any other rules for differentiation unless you've done AP Maths. You haven't learned anything like chain rule or anything like that. So simplify it down to a method that you can differentiate. Okay, so I'll just give a few seconds on that and then I'll jump into it. And then the other one that you need to find is, okay, so that's one. The second one is, let's do it up here. That's going to be find dy dx of, oh, this is a nice one, y equals to negative 3x squared, okay, minus 3 over the cube root of x, and then that is plus 3 to the negative 1. Okay, so attempt those two derivatives. I just need to take a sip of water. Okay, let's jump into it. Let me just check. I think I can end this. Okay, so let's have a look at the derivatives. So the first one is, okay, we're just going to simplify it. We're looking at dx. Okay, I like writing everything out just to be safe. X plus 1 over x. Okay, so what are we going to get here? We're going to have the derivative. X times x is x squared. X times 1 over x is just plus 1. 1 over x times x is plus 1. And then 1 over x times 1 over x is plus 1 over x squared. Okay, so we're looking for the derivative of x squared plus 2 plus 1 over x squared. Okay, now to make life easier, let's just take that up, make it a negative exponent so we can do the derivative a lot easier. Okay, so this is then equivalent to the derivative of x squared plus 2 plus x to the negative 2. Okay, now that everything is in exponent form like that, okay, it's easy to do the derivative. What do? We multiply the 2 with the coefficient in front, which is 1, and then we minus 1. Okay, so therefore it becomes 2x. Okay, so why is the derivative of a constant equal to 0? Well, the constant we can write as 2x to the power of 0. Okay, why? Anything to the power of 0 is 1. So if I do this now as well, I'm going to have 0 times 2, which is 0, and then if I minus 1 off there, yes, I'll have x to the negative 1, but I'll have 0 times x. And that is why a constant derivative is just equal to 0. Okay, so plus 0, and then that is, now we're going to go multiply that down, minus 1, so that's going to be minus 2x minus 3. Okay, and you can just leave it in that form over there. Okay, if you wanted to simplify it, it's just 2x minus 2 over x cubed. Okay, so not too difficult there. This one over here might be a little bit tricky with the cube root over there. Okay, but what I tell all my students, every cube root you change back to an exponent. So this is to the power of 1. Okay, so when we rewrite that, that's minus 3x squared minus 3 to the power of. Okay, so what happens? The outside number goes to the bottom of the fraction. I'm taking this whole thing to the top, so it becomes x to the power of minus 1 over 3. Okay, and then plus 3 to the negative 1. Okay, and now all we're doing is finding the derivative. So if we find dy dx, it's then going to be 2 times negative 3 is negative 6x. Okay, then we're going to have negative third times 3. So we have negative 3 over 3. Okay, so that's just going to be 1. Okay, so then that is plus 1. Why does it become plus 1? Because it's negative and negative. Okay, so it's plus 1x to the minus 1 over 3 minus 1. Okay, and then derivative of a constant we spoke about, that's just 0. Okay, which means we then have minus 6 plus x, let's see, a third, so that's 3 over 3, so minus 1 minus 3, that's minus 4 over 3. Okay, and then that becomes your derivative over there. So if you ever get it in a sense where you have a cubed root or a fourth root or whatever, always take it up to the top and create an exponent. It's easier to do the derivative that way. Okay, if they gave it to you in some complex way, for instance, they gave you the derivative where y equals to, let's see, x squared minus 16, okay, and then let's say that's x plus 5 all over x minus 4. So they gave you something like that and they wanted you to find the derivative. So find dy dx, okay? Always simplify as far as you can before you do the derivative, okay? Because you're dealing with a fraction now and you guys never been taught how to do derivatives of fractions. So we can see this is a difference of 2 squares. That's equal to x minus 4, x plus 4. Okay, and then that's x plus 5 over there, all over x minus 4. So that and that cancels out. Then factorize this out so that you get x squared, then that's plus 5x plus 4x plus 20. Now you can do the derivative of that. It's much easier. Okay, so if we then do that over there, we'll then have y prime equals to 2x plus, let's see, that's 9x, so that just becomes 9 plus 0. Am I a teacher? Yes, I am a teacher, but I don't teach maths. Okay, so I'm studying again. I'm doing engineering. So my first degree I did was BSc physics, and then I moved to engineering. But I'm teaching at the moment, grade 7s and grade 8s. I'm doing technology just as a part-time thing. I'd love to teach maths and science if I find a position. But yeah, I'm not teaching this at the moment. Okay, but I do YouTube videos for it. Yes, you are right. Thank you. Okay, so yeah, so just another way of looking at it. Always simplify as far as you can before you do derivatives. Okay. All right. That's a hard course. Which one? Engineering or physics? Because at the moment, both of them, to me, both of them are hard. So there was stuff I did in physics that I didn't do in physics that I'm not doing in the engineering course, and it's catching up with me. I'm not even going to lie. So those of you looking to go into engineering next year, be prepared to work. It's a lot of work that you do. Okay, but it's fun. It's really fun. Okay, here's another one. Quite an interesting question. Okay, just to test your... Yeah, I would say that the BSc program, or at this point in time, was far more difficult. The maths in it is far more difficult than engineering. Engineering's a application where BSc is more theoretical and understanding where things come from. So we look at, in the BSc degree, we looked at how to prove first principles, like from scratch. What is a derivative? How do you derive functions and stuff like that? So it was fun. It was difficult, but yeah, I miss it a little bit. Sounds a bit weird, but I do miss the calculus that I did. Okay, so this is the question. Have a look at. Okay, so they give you that f of x equals to 2x cubed minus 16. They give you that g of x equals to x squared plus 2x plus 4. And then they say if p of x equals to f of x over g of x, okay, find... yes, I can't spell tonight. What the... Find, there we go, p prime at 3. Okay, so this is one of the ones I was talking about. Yeah, they've given you two functions. So see if you can first simplify something before you try to do the derivative. Okay. The important thing here is note that g of 3 cannot equal to 0. Yeah. Okay, so g of 3 cannot equal to 0. Why? Because if g of 3 equals to 0, this whole thing collapses, because then I'm dividing by 0. Okay. So have a look at that question. Okay, so let's go over the question. Let's see what we can simplify here first. So we have p of x is then just going to be the quotient, okay, of two functions. So that is 2x cubed minus 16, okay, all over x squared plus 2x plus 4. Okay, so see if we can simplify this in any way. We can take a 2 out the top. Ooh, okay. We can have 2x cubed minus 8 all over... Let's see, if we factorize 0 at the bottom, what are we going to get? We're going to get an x and an x. The factors of 4 is 2 and 2. We need that to be positive, so that is... we need that to be positive. Let's see, my brain hurts at the moment. Okay, so 4 to give you 2 and 2, is that going to work? It should. Okay, so let's have a look here. Yes, that was a moth. Where the hell did that thing come from? Anyway, okay, let's have a look here. So 4 is going to give you 2 times 2 or 4 times 1. Okay, we want a 2 in the middle. We need that to be positive over there. If it's both positive, if say plus 2, plus 2, that's not going to give me the right answer because then that's going to give me that over there. Do I need to simplify the bottom though? I don't think I need to simplify the bottom. No, because I'm going to get some odd number over there. Okay. Ooh. Okay, let's get into this. Okay. Let's see, we can factorize the top over here. If we take out a 2 over there, then we have x cubed minus 8. Okay, let's see, how do we factorize our cubic functions? We can do long division. We must see what works first. Okay, this is how I normally do it. So let's substitute in a value which is going to work here. So if x equals to 1, it's not going to work. If x equals to 2, that will work. Okay, so x equals to 2, so therefore x minus 2 equals to 0. So therefore we've got to do long division. Okay, everyone loves long division. So 2x cubed minus 16, and then x minus 2. So how do we do this? X goes into 2x cubed. Let's have a look there. Rather than, we don't even, let's not incorporate this because we're taking out 2 as a common factor. Okay, so x goes into x cubed. That's going to be x squared. Multiply that down. That's going to be minus x cubed. X squared. That's minus 2x squared. Okay, now the thing is we don't have any x squareds. Okay, so x goes into, now when we sort this out over here, we're going to have 0. Then we're going to have plus 2x squared. Bring down the minus 8. X goes into x squared. That's going to then just be left with plus 2x. Multiply that out. So that's 2x squared. Okay, and then that times that gives you minus 4x over there. Okay. Now if we minus that off, we're then going to get that to be 0. We're then going to have plus 4x minus 8. Okay, last step. X goes into 4x. Okay, so that's going to be plus 4 times. Okay, and then we're then going to have minus 4x plus 8. Aha, so everything works. No, that's minus 8. There we go. Okay, so everything works out nicely. We have this minusing off, that's 0, and then minus 8 plus 8 gives you plus 0. Okay, so what are we going to get? We don't have to worry about this over here. Okay, I'm smoking my socks over there. So we're going to end up with the following. 2x x minus 2. And then we're going to be left with x squared plus 2x plus 4. Aha. Okay, that's nice to see. Why? Because then what's going to happen is this and this is going to cancel out. So here we have x squared plus 2x. And then that is plus 4. Okay, and then this and this cancels out. So what are we left with? We're just left with 2x minus 4. And then if we take the derivative of that, okay, p prime of x is then going to equal to 2. Okay, which means what? That p prime of 3 equals 2 because we just have a constant function. Okay. So, quite a nice question to do. Okay, you have to factorize a little bit over there, use some long division in order to factorize. Geez, I haven't actually done that in a while. Okay, so if you're not sure how to do long division, the first thing we're going to do is you substitute in, let's say 1, see if that can equal to 0 when x equals to 1. If not, do the next number. Sometimes you have to go negative. So in this case, it was nice because we saw that plus 2 cubed gives me 2 times 2, that's 8 times 2, which is 16 minus 16, okay, which then gives you 0. So therefore we know that one root is at x minus 2. Now we need to find the other polynomial that we need to then factorize in order to find the other 2 roots. So we divide this, you do long division with that to get the second one. Okay. Sure. All right. Let's see. I need to get more paper. Let me get more paper quickly. Okay. I should probably look at getting one of those tablet things in the future. I'm going to have to go through 1,000,001 pieces of paper. Okay. At the moment, there's just these A3 pages everywhere. All right. Let's have a look. It's a cubic function. Okay, so I'm still dealing with the Limpopo paper. For those who have just joined. So we're going to look at the cubic function in the Limpopo paper. That was quite a nice question. Here we go. Okay, so cubic functions, you're always going to be asked to find the coefficients of the cubic function. Okay, it's a given. So it's going to be 5 marks, 7 marks, whichever, but you're going to be asked to find the coefficients. So they give you the following function. I'll draw it here quickly. Stupid mosquitoes. Okay, so if we have the following function over here, let's see, it goes up, cuts there, and then goes back up that way. Okay, this is C. This point here is B, D, and then E cuts here, and then that's A. Okay, and then they give you F down here as being 2 and -9. Okay, so they then give you the equation y equals to 2x cubed plus px squared plus qx plus 3. Okay, and then they ask you to find or show that p equals -5 and q equals -4. Okay, so when doing these questions, okay, it's going to be simultaneous equations. You've got 2 unknowns, which means you need 2 equations. So here's one equation, okay. We can substitute the point given to us into the equation. They'll give us our first one to find p and q. The second one is you have to take the derivative. Okay, so let's just take the derivative now, and then it's out the way. So y prime equals to 6x squared plus 2px plus q. Okay, and now what we can do is we can use, also remember that the derivative at this point over here must be equal to 0. Why is that the case? Okay, so I don't think this is really explained, but if we look at the gradient of a function, m equals the change in y over the change in x. Okay, now when we get to calculus, the change, this delta, is replaced with dy dx. So my derivative is just equal to my gradient. Now y is the gradient at a maximum or minimum, always equal to 0. Well, let's have a look. If I have a function that looks like this, I'm going to have a positive gradient of m, or the function is going to be mx plus c. Okay, but if I take the gradient at this point over here, it's always going to be a tangent to that point. Okay, so tangent only touches once. So if I cut across like this, now what do I have? I just have a constant function. So if I have a constant function over here, that's just f of x equal to 9, let's say, over there. Okay, so if I have a constant function, it has no gradient. Okay, so at the minimum or at the maximum, it's always a constant function because it's a straight line. Okay, therefore we have zero gradient. That's why we always make the derivative equal to 0, because my gradient of a constant function is 0. Okay, so we find the derivative, and now if we want to solve at this point over here, we have the x point, so we can solve that equal to 0. Okay, so the two equations are going to be this. We're going to have minus 9 equals to 2 cubed plus p times 2 squared plus q times 2 plus 3. And then we are going to have over here, if we solve that out, minus 9 is going to equal to 2 cubed is 8, that's 16, plus 4p plus 2q plus 3. Okay, and now if we do the derivative equal to 0, therefore we're going to have, let's see, 6. We're going to substitute in 2 squared plus 2p times 2 plus q equals to 0. Okay, why? Because the gradient at that point is 0. Okay, and then we form our second function over here. So that's 2 squared is 4 times 2 times 6, is 24, plus 4p plus q equals 0. Okay, and then we can just solve this simultaneously. So you can say equation 1 minus equation 2, or you can make one of them the subject, plug the other one back in, and then solve it that way. Okay, so let's have a look here. Let me sort out this one further over here. So that's just going to be minus 25, it's minus 28. If I have numbers correct, let's just check. Minus 9, minus 16, minus 3, minus 28 equals to 4p plus 2q. Okay, so if we say equation 1 minus equation 2, you can see that the p's are going to cancel out and we can calculate q. So equation 1 minus equation 2 is then going to give us, let's see, that's 2. So we're going to have 4p plus 2q minus, that's 4p plus q. It's then going to be the coefficients now, so minus 28 minus 24. Okay, so then we're going to end up with q equals to, let's see, so 28 minus 24, negative 28, negative 28, and then minus 24. Okay, so that becomes plus 24, so that can become negative 4. I was going to say that was going to be way too big, that answer. Okay, so because I take this over that side, it becomes minus, so therefore negative times negative gives you positive. So therefore we have minus 4 for q. Now we just have to solve by plugging it back in. Okay, so I'm just going to use this equation here. So we have 4p minus 4 equals 24. So therefore we're going to have, let's see, take that over. We're going to have 4p to 20. Okay, sorry about that. Therefore p equals to 5. Okay, minus 5. And we have our two answers over there. All right. And then once you have that, then everything else becomes simple. Then you can find your intercepts. Okay, if you find your intercepts, then all you have to do is set this equation equal to 0 and factorize. And then if you want to find, okay, so the other thing that they talk about, let's actually look at this one and then we can talk about it quickly. So the other thing they like asking about is increasing and decreasing. So when is a function increasing? Okay, so a function is increasing when my consecutive output value, so when y2 is greater than y1. What does that mean? Okay, when x2 is greater than x1. So what does this mean? If I increase my x values, meaning that this one over here needs to be bigger than this one over here, then the y value over here needs to be bigger than the y value over there. So let's have a look. Where is this function increasing? If I take this x point over here, and I take this x point over here, okay, and I take their y values. This one's sitting at some y value over here, this one's sitting at 0. So you can see this one's greater than this one. Now if I take this point over here, we can see that this y value is greater than that y value. So that means that the function is increasing over here. How else can we determine this? Well, we can find where the derivative, so dy dx, is greater than 0. If it's greater than 0, okay, why are we looking for that? Because we want the gradient to be positive. If my gradient or my tangents over here are all positive, we then know that the function's increasing. So function's increasing here up until that point, then it decreases all the way to this point over here, and then it increases again over there. So decreasing is when my derivative dy dx is less than 0, which means my gradient is negative. Okay. So then the other thing that they can ask is concavity. Okay, so what is concavity? We're normally looking at concave up and concave down. So it's just looking at so concavity means if something is curved. Okay, so the old TVs back in the day, the screens were concave outwards, which means the screens stuck out like this. Okay, nowadays you get monitors which are convex. Okay, so then they look like this, so your monitor does that. Okay, so concave down means we're looking at what looks like a hill. Okay, so it forms a mound. Concave up forms a valley. Okay, now what splits concavity? It's inflection point. Okay, so when we're dealing with concavity, okay, we're looking at the second derivative, and we're looking for the inflection point. That's the key thing. So inflection point is the second derivative equal to 0. Okay, you just need to find the x coordinate because they'll always ask where is it concave up or where is it concave down. Okay, which means you just need the x point. You don't need to waste time finding the y point unless they specifically ask for the point of inflection. Then you have to solve for the whole coordinate. Okay, but in this case, this point here would be concave up. Okay, and this over here would be concave down. So where the graph is from this point here, there's concave down and there's concave up. Okay, so if you're not sure about that, let me know and I can explain it again. Okay, let's have a look here. Aha. Okay, so which one is this again? This one is from the KZN. Okay, so the KZN paper actually had a really nice optimization question, which I want to go through. Okay, so let's have a look at an optimization question here quickly. I need to go this way. There we go. Okay, if I ever go out of the view of the screen, just let me know. I do tend to have a tendency of wandering off screen. Okay, so question 11, they give you a rectangular prism. Okay, so they give you the following rectangular prism. Okay, this is the KZN 2020 mock paper. So KZN, so those of you who are interested and want to get the paper, KZN 2020 mock. Yeah. The only thing about summer is we end up with mosquitoes, and no one likes mosquitoes. Okay. Sure. So we're dealing with this well, they call it a milk carton. Okay, I'm just going to call it a rectangular prism. Okay, and they tell us that this is x, that is x, and then we have a height of h, and then for some reason this thing's got an additional flap attached to it, which comes this way. Okay, and then it goes this way. Okay. So they say that a milk carton with the square base holds 1 liter. So it holds 1 liter. Okay, so this is its capacity, which means it's its volume. Okay, then it says it has a special design fold up top or fold in top. The area of the cardboard used for the top is 3 times the area of the base. Okay, so the total area for this top here is 3 times the base. There we go. Okay. Then they say the surface, or question 11.1, show that the total surface area of the carton is given by the following. Okay, so we've got to find surface area. So they give us that the surface area must equal to 4x squared plus, let's see, that's 4,000 over x. Okay, all right. So just to go over that again, the area of the cardboard used for the top is 3 times the area of the base. Okay, so this here is 3 times the area of the base. Okay, so let's see. The area of the base is just going to be, so area of base equals x times x, which equals x squared. Okay, so this one is 3 times, the top is 3 times the base, plus we have the base, which then means we have okay, so someone asked earlier as well, are there specific formulas we need to know for optimization? It's just your area formulas. Maybe speed. Know what speed and velocity is. So velocity is given as distance over time. Okay, so just kilometers per hour. So therefore it's distance over time. But often they just give it to you in the form of shapes. So know how to calculate the area of a triangle, calculate surface area, calculate volume and stuff like that, because that's how they're going to ask you to find your equation that you have to set up. Okay. So we got to show that this is the surface area. Okay, so far we have, this is the area for the base. Then we know that the area for let's see, these faces over here is 1, 2, 3, 4. So they'll all be the same. So we have 4 faces. That's going to just equal to 4 times h times x. Okay, which is then just equal to 4hx. Okay, let's see. They haven't really specified. They haven't told us what h is in any way. No, they haven't. But we can solve for h. Let me check here. Can we solve for h? Because we need to cancel out all the h's, so we need to get rid of h in some way. Remember, Okay, so we need to get rid of h because we want everything just in terms of x. Okay, let's see. Have they specified what? I'm just checking if they've specified what the top needs to be or what the dimensions are. Okay, so let's get rid of h. We know that the volume equals to the base times height. So that's just going to be 8 or x squared times the height. Okay, so we want a term for h. Okay, the volume is given as 1 liter. Okay, which you can then convert to milliliters. So it's 1,000 milliliters equals 1 liter. Okay, so we have 1,000 over here equals to x squared times h. So h is then going to equal to 1,000 over x squared. Okay, so now we have a term for h. Now we can write everything in terms of x. Okay, so now this here is going to become 4 times 1,000 over x squared, and then it's multiplied by x. So therefore, this is just equal to 4,000 all over x. Okay, so then we have the area of the top. Okay, so let's do that over here so we save some space. So area of top equals 3 times the base, which equals 3 times x squared. Okay, so if we do total surface area, it's then going to equal to the base, x squared, plus the top, 3x squared, plus this 4,000 over x. Yes, they gave us volume. Well done on identifying that. Okay. And then this is that term over there, and then we see we end up with 4x squared plus 4,000 over x. Okay, so the key thing here was you could see that in your final answer, there was no h involved. Okay, so we had to get rid of h and we had to get it in terms of x, and that's where this 1,000 factor came in. Okay, so the 4 faces is these over here. Again, there's 2 that side, and that's what you're taking into account. Okay, so now that we have that, the next question says, determine the dimension of the carton so that the minimum amount of cardboard is used. Okay, so we're minimizing this. So we're trying to save as much as possible. Okay, so we're finding the minimum amount of cardboard. Okay, so because we need to minimize it, we then have to do the derivative equal to 0. So what we're going to do is we're going to find dx of our surface area. So I'm going to equal to dx of x squared, 4x squared plus 4,000 x to the negative 1. Okay, and we equal that to 0. So this is the correct way to write out. This is just the right term or the right way of doing it. You're saying you're doing the derivative of the surface area, which is equal to the derivative of the function. Okay, equal to 0. So if we find that, that's going to be 8x minus 4,000 all over x squared equals to 0. And now we've got to solve this out. Okay, so I'm going to take that over. So we're going to have 8x equals to 4,000 all over x squared. So we're going to have 8x cubed equals to 4,000. Okay, and if we divide that, so we have 4,000 divided by 8 is 500. So x cubed equals 500. Therefore, x is going to equal to the cube root of 500. Okay, and then that's going to be 7.94 They haven't really specified units, so because volume's in millimeters, we converted that. Let's use uh, 7 meters is a lot. 7 millimeters. That's a little bit that's a little bit too little, but then we would substitute that back in there to get total surface area. Okay, so let's take this as millimeters. Okay, since they haven't specified. And then they say determine the dimension of the carton so that the minimum amount of cardboard is used. So x must n equal to 7.94 millimeters, which is not really a lot. I mean, if I get my ruler, okay, 7.9 millimeters is minute. Maybe it's centimeters. Centimeters makes more sense. Okay, because then you have a carton that wide. Okay, but then h is 1,000 divided by, this carton is going to be very weird. 1,000 over answer squared. It's 15. Okay, so it's that tall and that wide. No, it'll give you, guess it's going to give us a liter. Okay, so that's how we go about doing our optimization questions. Okay, they're not too difficult once you've broken down what needs to be covered. Okay, so in a sense, you're going to have to find, they'll break it up like this. They'll ask you find the area, surface area or volume, okay, and then see if you can get to this equation and then do this one. Okay, the reason why they say see if you can get to that, if you can't get this, then you at least have this to get your 6 marks at the bottom. Okay, I think it's really unfair if they don't give this to you and expect you just to get to the final answer. Okay, I see I'm cutting it off there. All right, any questions with the optimization? Must I do another one? Let me know if I must do another optimization question or if I can move on to probability. One more. Okay, let's do another one. Let me find another one here quickly. Which paper is this? Let's look at the Eastern Cape one. So I'm looking at the Eastern Cape mock paper 20. So I think this was the Eastern Cape prelim paper. Okay. Okay, that's not really, that's not an optimization question. Let me find another one here quickly. Let's have a look at the Northwest paper. Okay, so all the papers that I'm looking at, please do one more optimization question. Okay, yeah. So all the papers I'm looking at are coming from that link that I posted in the chat. So maths paper 1. Okay, not that. Sorry, it's just loading. These are terribly scanned. Okay. There's another one. So see if we can get the equations, and then from there we can calculate the maximum volume. So they give you a brick. Okay, so we have a brick that's given to us. Okay, so they say that this is x, that's h, that's 5x. Okay. So the first thing you've got to show is they say the total surface area. So surface area total equals to 720 centimeters squared. Okay. And then they say show that the volume, so Vx, equals to 300x minus 25 over 6x squared. Okay, so in optimization questions like this, if they give you an h, a variable that's different to x, you 10 to 1 are going to have to find it in terms of x. Okay, so this one is a little bit more difficult because you have to first find the total surface area in order to get h, and then you've got to plug it in here. Okay, so I'm going to give it about a minute. See if you guys can figure out the question. See where you're going to go, and then I'll go through it. Ooh. Flip, we've already done 2 hours. I think after this one, I'm going to move on to probability. And then I'll do the last half an hour probability. Okay, so let's see, how do we go about doing this? Okay, so the first thing that we have to sort out is surface area and h. Okay, so we know that if we want to calculate the total surface area, we're going to have, let's have a look at, we're going to have 2 of these, 2 of these, and 2 of these. So we're going to have following surface area total equals to 2 times x times h plus, let's see, 2 times 5x times h. And then the last one is going to be this narrow piece here times that. So then that's going to be plus 2 times 5x times x. Yeah. Therefore, if we sort this all out, that's just going to be 2xh plus 10xh, and then that is then plus 10x squared. Now remember, we need something in terms of h, and then this is all equal to 720. So I want h on its own. Okay, so therefore we're going to have 720 plus minus 10x squared equals to 12xh. Okay, so therefore h is going to equal to 720 minus 10x squared all over 12x. Okay, so now that we have that, okay, we can now sort out the volume. Okay, now volume v of x is just going to equal to the base. This is going to become your base times your height. Okay, so this is lying on its side. So therefore, it's going to be x times h times 5x. Okay, and therefore that's going to be 5x squared h, which means now we can substitute what h is into here. Okay, so therefore we're going to have 5x squared multiplied by 720 minus 10x squared all over 12x. Okay, so we can see that we need to end up with an x squared over here. What else? Oh, sorry, x cubed. Thought that was only going to make sense because that's going to give you x4, so therefore that needs to become to x cubed. Okay, so let's see if we can sort this out. What's 5 times 772? Oh, it's 3,600. So we're going to have 3,600 x squared, then minus 50 x to the 4 all over 12x. Okay, so now I can split this into two fractions. So you can see that if I take 36,000 or 3,600 divided by 12, I get 300. X squared divided by x is just going to give me x. Okay, so I'm splitting this. And then minus 50 divided by 12, it's 25 over 6. And then this is x cancels out an excess, so x cubed. Okay, and then we get the equation there. So if you can get the equation, then you know you're on track. Okay, so practice seeing if you can get the equations, but if you can't, then no, focus on doing the derivatives. Now it says calculate the maximum volume of the brick. Okay, so now we want to find the maximum value. Okay, so it's going to require a little bit more calculation here because we've got a cubic function, which means when we differentiate it, we're going to get a parabola. So you're going to end up with possible two answers. Okay, so you're going to have to check them. Okay, so let's have a look here. If we want to find the maximum. Okay, so by finding the maximum volume, okay, we have to find v prime of x. Okay, so if we find v prime of x, this is just going to be 300 minus, let's see, 3 times 25, that's going to be 75 over 6 x squared. Okay, and now what we're going to do is set that equal to 0. So if we solve this out, we're going to have 300 equals to 75 over 6 x squared. So we're going to go 300 times 6 and then divided by 75. It gives you 24. So therefore we're going to have 24 equals to x squared. So therefore x is going to equal to the square root of 24, which is 2 root 6. Okay, and we are working in centimeters. So that's centimeters. Okay, so now by doing this, we can now calculate the maximum volume of the brick. Okay, we now have the volume formula. We can plug this back in and we can find Vmax. So Vmax is going to equal to 300 times 2 root 6, okay, minus 25 over 6, 2 root 6 cubed. Okay, and if we plug all of that in the calculator, 300 answer, and then minus 25 over 6 times my answer cubed. And get a total volume of 979.80 centimeters cubed. Okay. So these questions are very nice. They're quite enjoyable. That's an easy 10 marks. Sometimes a little bit more, sometimes a little bit less, depending on what you have to do. Okay. All right. So I think I'm going to spend the last 20 minutes, then 23 minutes or so, because I'm going to end the stream at Yeah, in 20 minutes. Okay, so I'm going to look at a probability question. So I'm going to see if I'll get a probability question in, and then I'll get a counting and the ones where you have to organize things, permutations and combinations. Okay, I'll show you how I go about doing them. So let's actually stick with this paper that I'm using at the moment. It's got quite a nice probability question, reading through it now. So let me write out everything that's given to you. So it's given that the probabilities, we have two events, we have A and B. Okay, so this is going to be, again, what's this? Which paper is this? Let me just find which paper it is. Northern Cape, sorry. This is the Northern Cape paper. Okay, so we're dealing with the Northern Cape paper, and this is the 2021 mock paper. Okay, so let me just go back down to it quickly. So we've got two events, A and event B, and then it says here that the probability of A or B happening is equal to 3/5. They say that the probability of A equals 2/5. Then they say determine the probability of B if A and B are mutually exclusive. Okay, so what is the important thing with mutually exclusive? Mutually exclusive means that the probability of A and B equals 0. Okay, that's the important thing. Okay, so by using this, okay, so we know that the probability of A and B equals the probability of A multiplied by the probability of B, but you can't use that to solve. Otherwise, you're just going to get the probability of B is going to be 0. Okay. So you then got to use the long formula. That whole thing where you have to, what is this? Okay, so by solving this out, we have the probability of A, we want the probability of B. Okay, so they've said it's mutually exclusive, so you've got to use that long formula. Okay, and the long formula is the probability of A and B, correct me if I'm wrong, equals the probability of A, is it multiplied by the probability of B minus the probability of A or B. Is it that one? Let me check quickly. I might have swapped them. It's not multiplication, it's addition. Okay, so I have actually used the right formula here. So by looking at this now, we know that the probability of A and B equals to 0. Okay, remember we can't use this one. Probability of A and B equals the probability of A multiplied by the probability of B. Okay, is it this one or is it or? No, it is this one. Okay, we can't use this one because if this is 0, then we're just going to get B to be 0. So you've got to use this one over here. Okay, there's a reason why they gave you probability of A or B. There we go. Okay. No, that's not wrong. Okay, so the probability, okay, so remember, in probability, if you have the word and, it's multiplication. If you have the word or, it's addition. Okay, so the way you've done it there, probability of A or B equals probability of A plus the probability of B is perfectly correct. But where does that come from? It comes from this here. So because they're mutually exclusive, this now becomes 0, okay, which implies that we then have the probability of A plus the probability of B equals the probability of A or B. Okay, and now we have everything here. This is 3 over 5 equals to probability of B plus 2 over 5. Okay, and if you take that one over and you minus it, you're going to get the probability of B is going to equal then to, hold on. Yeah, sorry, what have I done? I'm overcomplicating this. Sorry, that's 1 over 5. I'm sleeping here. Hey, it's been a long day. What are we getting there? Okay, so probability of B is then given as that. Okay. The next question says find the probability of B. So find probability of B if the events are independent. Okay, so what does independent events mean? So if the events are independent, it means that the probability of A and B is not equal to 0. Okay. So now we're going to find the probability of B. So how are we going to go about doing this? Oh, we can use Okay, well, yes, because this is not equal to 0. Aha, I've got it. Because this is not equal to 0, okay, because they're independent, so P of A and B not equal to 0. Therefore, P of A and B equals P of A multiplied by P of B. Okay, so therefore we can substitute that into here and we can still solve this equation over here. So therefore we can solve that we have probability of A is given, so that's 2 over 5 multiplied by the probability of B equals probability of A, 2 over 5, plus probability of B. Okay, yes, that is correct. Sorry, I just saw the chat now. Okay, so that only works if it is mutually exclusive. Okay, why? Because probability of A and B is then equal to 0. But in general, if you're looking at probability, if you're looking at an or, it's plus or minus, it's addition. If you're looking at and, it's then multiplication. Okay, so just going back to this, so probability of B, and then what do we have to do? We have to minus the probability of A or B, and that was given as 3 over 5. So now we can just solve. Okay, so this is going to be, I'm going to take that over, so 2 over 5 P of B minus P of B is then going to give you minus 1 over 5. Okay, so if we sort this out here, and then we can just solve. So 2 over 5 minus 1 gives you negative 3 over 5. P of B equals negative 1 over 5. So if we then solve that, we're just going to get, that's going to go up, that's going to go down. So P of B equals to 1 over 3. Okay. So quite a nice question, that one. Okay, just check if you understand the difference between mutually exclusive, independent events, and so on. First, I want to applaud your methods. I'm currently a maths teacher who teaches at school that was placed #1 in South Africa in 2016. I still watch your video. Oh wow, that's insane. Thank you for the compliment. You say there that you're teaching at a school that was placed #1 in SA in 2016. That's really cool. If I may ask, what school is that? Actually, I don't know about the rankings of the school. I don't know that they did that. Um, all right, I haven't heard of you guys, and I'll definitely look it up and write it down. How long have you been teaching for now? The way that I do things and go about them, to be honest, I never got 80s and 90s in high school. I was a 50s and 60s student, so I figured out how to do it all on my own. And I guess that's the best way to learn something. Is once you figure it out and you've done it and you've got there in your own way and it makes sense, then you tend to never forget it. Okay, 9 years. That's really cool. So I hope you're helping lots of students and changing the minds of the future generations. I'm only in my first year of teaching. I'm not teaching maths or anything. I'm teaching grade 7s and grade 8. So maybe I'll build up to teaching high school students, but that's a big difference between tutoring the subject and teaching the subject, I must say. So I give props to all the maths teachers, all the teachers out there, to be dead honest. It's not an easy thing to do. Okay. All right, so this question has one more part to it. Let me just have a look at it quickly. Okay, so they say event S and T. Okay, I'll do it over here. So they say that S and T are independent. Okay, and then they say such that the probability of S equals the probability of T, which equals Y. Okay, and the probability of S or T equals 0.84. Determine the value of Y. All right, it's quite an interesting one. So we have S or T. They've told us it's independent, okay, which means probability of A and B is not 0. Okay, so we can use this over here. Okay, so we're pretty much using the same setup as in the previous question, except now we're just solving for Y. Okay, so we have the probability of S and T equals the probability of S multiplied by the probability of T, okay, and then minus the probability of S or T. Aha. Okay, so we've got an equation, because we know that that's Y, that's 0.84, and this is just going to become Y squared as well. Okay, so by looking at this over here, sorry, that's not multiplication, it's plus. Okay, so we're going to have Y times Y over there, because probability of A and T is this one times that one. Okay, and then that's going to equal to Y plus Y minus 0.84. Oh, it's actually quite a nice question. Okay, so we're going to have Y squared equals to 2Y minus 0.84. And then what is this? This is just a polynomial, which we can then just use the quadratic formula for. Okay, so let's see. We're going to have Y equals to plus minus B. What am I saying? Minus B plus minus the square root of B squared for AC all over 2A. Okay, and if we substitute in our values there, if we first of all take everything over. That's y squared minus 2y plus 0.84. So therefore that's going to be negative 2 plus minus the square root of negative 2 squared minus 4, a is 1, c is 0.84. Okay, I'm running out of paper there. All over 2a. Okay, so a is 1. Plug this into the calculator. We're going to have negative 2 plus the square root of negative 2 squared minus 4, 1, and then that's 0.84 all over 2. So we get 7 over 5. Okay, so the first one, y1 is going to be 7 over 5. That's when we use the plus sign. And if we use minus sign, then we're going to get minus, and y equals to 3 over 5. Okay, so let's go back to what they were asking. Determine the value of y. Okay, so y can be either one of these values over here. By solving that, we can check which one will work. Okay, because we have to check which one works, because one of them should and one of them shouldn't work. Okay, so let's check this quickly. If I have 7 over 5 squared, okay, and then let's plug it in there. So minus 2 times y, so 7 over 5, plus 0.84 84 equals 0. Okay, so that one works. And then if we solve for the other one, that's 3 over 5. Okay, so both of them work. All right. So either way, if you use in either one of these, you're going to get this equation here equals to 0, which means that there is sound. Okay. So that's how we do this probability question. Sham, thank you very much. That's very kind of you to promote my channel. Yeah, I started it as a side thing. I've always enjoyed tutoring, so I thought, well, let me make videos about this. So, yeah. All right. Let me go through one more question, and then we're gonna call it a night. I need some sleep too. Let's look at a probability, like a counting question or something like that, where you have to find the number of seats or something like that. Okay, that's all Venn diagrams. So I guess we're going to be using this paper again. Yeah, okay, so this is going to, is it still the same paper? Yes, it is. Okay, so I'm going to stick to the same paper. I'm just going to do question 11. So this was the Northern Cape 2021 mock paper. So now I'm just going to do question 11. So this was question 10. Okay, so I'm going to do question 11, which is then going to be counting. So they give you the following information. Okay, so question 11 of the Northern Cape 2021 mock. Okay, so it says a 4-digit code is created using the numericals 0 to 6. So we have a 4-digit code, and we're only using from 0 up until the value of 6. Okay, so what do we have? We have 1, 2, 3, 4. Okay, and there's 6 possibilities for each one. So it says, how many 4-digit codes can be formed if the values can be repeated? Okay, so what does this mean? So we're using 1, 2, 3, 4, 5, and 6. Those are the only values I can use. Okay, so now it says values can be repeated. So if I start off, if the first number is, let's say, sorry, we need to include 0. If the first number is 0, for instance, then the next one can be 0, and this one can be 0, and that one can also be 0. So how many numbers are there in total? So it's 1, 2, 3, 4, 5, 6, 7. Okay, 7 numbers in total, so therefore there's 7 possibilities for the first number. We can repeat, so therefore it's 7 again, 7 again, 7 again, so therefore the total becomes 1, 2, 3, 4, 7 to the power of 4, okay, which is then just equal to 7 to the power of 4. That's 2,401. Okay. Then it's asking us to find how many 4-digit codes can be formed if the code has to be generated. What if the code has to be greater than 2,000? Sorry, let me read that again. Wow. How many 4-digit codes can be formed if the code has to be greater than 2,000 but less than 3,000, and the code must be an even number? And each number must only be used once. Okay, wow, that is quite. So the code itself, the 4 digits, 1, 2, 3, 4, must be less than the code 3,000. Okay, must be greater than 2,000. Okay, so the first number's got to be greater than 2, but less than 3. Okay, so this number here, let's call this the first number. So x1 needs to be less than 3. Okay, we can include 2, so it's going to be greater and including 2. Okay, it must be an even number. So if a number is even, it must end in, it must end in 2, 4, or 6, or 0. Okay, because if you have 50, 40, 30, those are all even numbers. It can all be divided by 2. All right, so the last number just needs to be able to be divisible by 2. The first number needs to start with a 2. That's what we're actually dealing with. So 2, okay, and it needs to end in one of these digits over here. So that's 1, 2, 3. That's 4 options over there that it can end in. Okay, there must be no repeats. So therefore, how many numbers are left? Okay, so this number cannot be a 2, and it cannot be any one of these numbers provided that it goes there. So if this number is a 6, we can't use 6 anywhere here again. Okay, so how many numbers are left? There is 1, 3, and 5. So those are the only numbers that are left that can go into here, and we can have them in any combination. Okay, which means that that's 1, 3, and 5. So if we place a 1 here, then this one must be part of 3 or 5. Okay, so if we look at it that way, how many possible options are there going to be? Well, this needs to be a 2. How many numbers are left provided that this one is an even number? Okay, that means that if this one's a 2, that means we can still use any one of these numbers over here. We can use 4, 6, or 0. So therefore this here will then be 5 options. Why? Because let's have a look here. It starts with a 2, so therefore I can't have 2. If this number here is 4, then I'm taking out a 4 as well. Plus we've got to end on an even number, and there can't be any repeats, which means the last number, if this number here is a 4, so let's say we have 2, 4, something, that means the last number is either got to be a 6 or a 0. Okay, which means how many options are left? There's 5 options left. Okay, therefore the last options that are left over here, provided now that we can't have any repeats, will be, because this one had 5 options left, we've taken out one of those options, so this one's going to be 4 options left. So how many possible outcomes can we have? We can then have 2 times 5 times 4 times 4, which is then going to give you 2 times 5 times 4 times 4, 160. Wait, what have I done? No, I've missed. Oh, I've made a mistake. I've used the example and I've found it. Okay, this one, yeah, there's only one option. It must be the number 2. So there's only one option there. Okay. Then how many options are going to be at the back here? It must be one of these here. It's got to be an even number. Okay, if it ends in 6, it's even. Let's just check. 56 divided by 2. Yeah. If it ends in a 4, it's even. If it ends in 0, if it ends in 2. So because 2's here, we can't have a 2 at the end. So it's got to be one of these options over here, and then it can be 5 of those. And there we go. I was making a mistake there. Okay, all right. Geez, my brain is a bit fried. So this one here must be 2, so it's only one option. Okay. Then it needs to end in a 4, a 6, or a 0. So it's one of those options need to go here. But if any of those go here, then any other one can go here. Okay, so therefore we have one option at the end for an even number, and then we have 5 times 4. So that means we go to the following. It's going to be total number of codes. Okay, so that's 20. So this equals to 20. Okay. So we've got 20 over there, 20 possibilities. And this can happen 3 times. Why can it happen 3? Okay, this is quite a question. I'm not even gonna lie. So it can happen like this, okay, but it can happen 3 times, because if this number ends, let's say the first one is a 4, okay, then we can do it again for 6, and we can do it again for 0. So in this combination where one of them is an even number at the end, there's 20. But there's 1, 2, 3 possible outcomes over here, so we have to multiply that by 3, which then gives you 60. Okay, so it's quite a mash of the brain here, but let's have a look at it again. So let me explain it. We've got 4 options. Okay, the last option has to be even. So it must be a 2, a 4, a 6, or a 0. Okay, but we need to start with the number 2. So there's only one option for that, which means the last numbers cannot have a 2 in it. Okay, then how many numbers are left? One number's got to go here. So we've taken out 2, and we've taken out another number, another even number. So there's a possible of 5 options left here, but we can't repeat. So therefore this one must be 4, and this one must be one of the even numbers. Okay. So that's possibility 1 if the last even numbers are 4. Okay. Possibility 2, okay, so that gives you 20. Possibility 2 is then going to be when the last numbers are 6. That's another 20 options. And again, it's going to be when the last number is a 0. So it's going to be 20 options again. So we sum up this here, and that's going to give you 60 possible options. Okay. So quite a difficult one over there. Okay. But the key thing was that you had to realize we can't have any, or there's no repeats here. This needs to be an even number. This one has to start with 2. Therefore, the 60 outcomes. Okay. All right. Let me change over so I can say goodbye to everyone. Let's change this to that one. Okay, well, once again, you're looking at my nostrils. Let's just change it to this here. Okay, but now that's, there we go. Okay. You either look up my nostrils or I look like I'm stretched across the page. All right, so I hope you guys have found this live stream helpful. I think I've covered quite a lot. I've explained quite a lot as well that could possibly happen. Thank you for those who have joined in. It was a really good evening. I won't lie, my brain's a bit tired now, so I'm going to go and grab some sleep. If you are going to study tonight, go through the last few things, but make sure you get enough sleep before you write. You don't want to be sleeping on like 2 hours. Then you're not going to think properly tomorrow. So make sure you get a good night's rest before you write tomorrow. Good luck with the paper tomorrow. Leave a comment in the community section of my channel. Let me know how it went. And I will see you guys in future videos. Okay, I'll see how it goes. Maybe I'll do a live stream on Sunday for paper 2. I just got to see how my studies are going. But I'll keep you guys posted about that and then put up a poll as well, seeing what you guys want to cover in paper 2. I think it's probably going to just be circular geometry. Everyone hates circular geometry. So we'll go over some circular geometry and probably some trig. I know those are 2 sections that you guys struggle with a lot. Okay, so have a good evening further. Remember, it's never too late to have an IC moment and enjoy. Good luck for tomorrow. Thanks, everyone. Bye-bye.